Hello everyone. This video will provide an example of how to build a Simulink dynamic system and how to simulate a basic feedback loop using the MATLAB 2016b version of Simulink, which can be used for CHE446 Lab 4. To start the Simulink, we open up the Simulink library by clicking the Simulink button in the MATLAB toolbar. So we use the Simulink Start page accessibility from the Home tab on the MATLAB toolbar script. We click on it, and then once the Simulink library browser is opened, we make a new model using any templates or examples that exist there. So we have different templates and we have different examples that already exist by the Simulink. Here we select the blank model, which shows by a blue triangle and yellow plus symbol on top of it. So once we click on it, we will see a new window will be open. Before we build our simulation, we will want to save our new Simulink model under representative name of Lab 4. So we go to the file and we select Save or Save As in the recently open blank Simulink window, or we press Ctrl S while the recently open blank Simulink window we are in it. I want to save it in the desktop and I give the name of Lab 4. But what is important is that we recommend that you save your model as the MDL file. So we select MDL from this drop down bottom, and then why is that? Because when we save it as the MDL file, MATLAB 2016 default is to save the Simulink as the SLX, but this file is not recognizable by the older version of MATLAB. That's why we save it. So now that we we saved our file, we try to construct a simulation model by clicking and dragging the individual components which are in the library. So I clicked on the library of Simulink, and then I saw that in Simulink we have different type of blocks. So one of them is the commonly used blocks that we see here. We have different tabs and different groups such as sources, scene, or continuous, discrete. So the only thing is that each block represents a mathematical operation being performed on a signal. So to connect the blocks in Simulink, we can either click and drag the arrowhead of one block. Actually, the thing is that we just we go to the group and then the source, for example. We select one of these components, we drag and drop it, then we select another from the sync, which is scope, and then we click on the arrowhead and then we drag it and we connect it to the other arrowhead of the block, or we can click on the block itself and then hold the control and then click on the block we wish to connect it. A solid black line will indicate a good connection, while a dashed red line will indicate that the block have not been connected. So in order, at the end, if you want to find a general Simulink file, a general completed feedback loop in the Simulink, we will have it as this. So this is the general feedback controller. As you see, we have set point, subtractor, PID controller, saturation, valve, and also we have set point that given to the system. We have process delay, we add two signals together and then we feedback it to the system. We have sensor, also we have disturbance to the system, and we get the result out from the system. This is very general. We will not now learn about each of the components in this general diagram, and we use this information to move step by step through the building a simpler Simulink model that we will use for our lab simulation. So let's go back to a simple simulation model. We talked about different blocks that we have here in the library. One of them is a step, one of them is scope, which was in the sync compartment. Let me change the input from, before I go to the step, I tried different sources. Like, for example, imagine sine wave. I drag it and drop it in the workspace and I connect it to the scope. So if I double click on the sine signal, I will see that there are different features such as amplitude, bias, frequency, and phase. If I change the amplitude from, or if I actually run it with this amplitude, and I open the scope shows me the signal. And if I change the let me make this here. And if I change the amplitude to 3 and the frequency to 3 also, then I apply and then I press OK, I run it again, and I will see that we have more signals here. But the problem is that if I zoom the signal, I will see that it is not like a sine signal, smooth, but it is actually kind of broken line. So how I can fix this? This is based on actually the problem for sampling. I mean, if I go to the sine wave and I go to the sample time and I increase it from 0 to actually decrease it to 0.1, I will have more samples. So if I run it, I will see that I have smoother kind of trend, but still I have these steps. So the more, the smaller sample time, the smoother diagram that we have. So we apply it and then put OK, run it, and we see that it's like smoother. So this is the result of changing the sampling time. But if I click here, it's like a zoom out. I can see all sine signals or signals in a whole window. Another feature that I have in the sync is to workspace. So let me drag and drop it, and then I connect this to the sine wave. When I have like this type of block, which is to workspace, the good thing is that I can get the result in the MATLAB. So variable name, I can change it to the sine out, and then I change the sampling time from -1, which is the default, to 1, and then I accept, I press the OK, and then I will run it. When I do this, when I go to the MATLAB file, I will see that I have sine out. So when I double click on this file, I will see it's a double time series. Actually, I could change the type from time series to array or different things. I copy paste the data here, and then I go to the Excel file, if I put time here, signal, if I paste it here and then I press the insert, I plot it. This is the signal that I have. So let's go back to the sine data frequency and then time out. So now let's delete this and we put step. As the source, or before that we can have ramp, and then when we connect ramp to the scope, if we double click we see that features of ramp, one of them is slope. So if I use 1, then the scope shows me that this is the ramp that is given, but if I change the slope to 30, for example 0.5, and I run it again, I will see that the slope, it is not very steep. So let's go and change the input from ramp to this time white noise, and then we connect it to the scope. If I open the white noise, I will that there are some features and parameters for white noise. One of them is the noise power, sample time, and the speed. So I change the power from 0.1 to 1, and the sample time I keep it as this, and I apply open, I run it, and I will get this data result. But if I come here and then change the sample time to 0.001, and I should have dense, oh actually this is the denser signal I have. There are other signals here that actually can be used, like impulse generator, but let's go to the step which is the most useful one and the input that we are using in our system, because as you know that in PID controller we have the integrator, and it's very good to tracking the step. When I actually in this kind of source block, which you see, as you see on the left of the Simulink library browser, it's the first type of Simulink block that we will be interested in this lab, and the step is another block of it is very interesting for us, as I explained. So this step has some features that if I double click on it, a new window will open describing the parameters of the step input signal. So these parameters are step time, initial value, and final value. The initial value is the signal that the step block immediately starts transmitting when the simulation is initialized. This can be set to any value you like, but since we design our linear transfer function around steady state deviation variable, 0 makes the most sense. The step time is the time that actually at which the signal will be changed to. Then it goes to the final value. So for example, if I set the step time to 50, and then initial keep it as 0 and the final value as 5, what does it mean? It means that the signal will start from 0 for first 50 units of time, and then it steps up to a signal of 5 for the remainder of the simulation. Just have this in mind that the step time is unitless. So this because that Simulink does not assume a unit for time, and then it depends on the unit of our transfer function. So it's better or recommended that we keep it as like the unit of seconds. Then we have to convert our dead time and time constant based on this unit as well. So just another thing that as you saw previously, that whenever I change something here, I press the apply and then OK, and then I run it to see the results. Let's see the results here by clicking on see that, but the step is coming from, okay, let me save it and I run it again. Let's see the step. Why is that? Because I have time till 10, but if I increase this, I can change this to 50 and then I rerun it, so I will see that, okay, so I have to, because this is 50, but you will not see, let's change it to 19, and then we run it again, and we'll see the step. Yeah. So till 50 we have 0, then there is a jump in the system, signal 5 is showing up. Thanks for your attention, and in order to build a Simulink, a simple feedback Simulink model, please watch the next video in this series. Thank you.